This video tries to tell us and explain logarithms. So, what is a logarithm? So first of all, a logarithm is a number that you raise a base to get another number. It is also an exponent. So the main thing to remember here is that a log is an exponent. Sorry, my writing is so bad. But a log is an exponent. So first thing we have is like the most important thing here is y equals log of x if, very important, if 10 to the y equals x. Okay. Very important here, we consider this base to be 10, but we don't always put it in. Okay. So if you see log with no base there, it's considered to be 10. So what we're essentially saying here is our base is 10. So we take 10 to the y power is x. Okay. So for instance, if we had 10 to the x equals 3, trying to find what value we have to raise 3 to, raise 10 to get 3. So we know it's going to be 1 is too big, right? Because 10 to the first is 10. So it's got to be something less than 1. And the way we do this is this is a kind of a procedure. You take log of the left side and log of the right side. And now one of the properties which we should know is that if you take a log of something to a power, it's a power times a log. So this becomes x log 10 equal to log 3. And remember, we're trying to solve for x, so we're going to divide by log 10 and divide this side by log of 10. Okay, those cancel, it makes a 1. So we have x now equals log of 3 over log of 10. But now think about this log of 10 for a minute. I'm going to switch colors. Log of 10, look at that, log base 10 of 10. Let's set that equal to some other variable z. What we're saying there is 10 to the z equals 10. And the only number that works for is when z equals 1. Okay, so my whole point here is log of 10 base 10, or log of b base b, is always going to be 1. So log of 10 is 1, so this value is just log of 3. Okay, so this value, log of 10 base 10, any number of the same base, and the argument is just going to be a 1 in the bottom here. So log of 3 gives us a number about 0.477121. 0.477121. And to check that, remember what we do is we would take 10 to the 0.477121. Try that on your calculator and you should get a 3 out. Okay? Next piece is, let's look at a different base. So let's say we have something like 3 to the x equals some value, 42. So we need a logarithm because we're trying to find out what power do we have to raise our base of 3 to get 42. So once again, anytime you're trying to find an exponent is when you want to use logarithms. So by the same logic what we just did, we're going to take log of 3 to the x equals log of 42. Our property states that a log to a power is the power times the log. We're going to divide both sides by log of 3. And those are going to cancel, and we'll get x is equal to log of 42 over log of 3. Put that in your calculator, being careful with your exponents, and you'll get a number about 3.40217. To check that, we can take 3 to the power of 3.40217. This is not an exact value, but we'll get pretty darn close. If we store this value on the calculator and put that in, we'll get the exact value back of 42. And you want to common sense check that, right? 3 cubed is 27. and 3 to the 4th equals 81, and 42 is right in between those, and that's why we get that value. Okay, running a little long on here, so we'll stop right now.